Okay, let's talk a little bit about displacement. And we're going to define that as the change in position. So this fancy term here, delta x, x because we're typically looking at the horizontal direction along a number line, a horizontal number line, and taking into account where we start and where we end, we're going to say that the displacement, or the directed change in position, is going to be equal to the final position less the initial position. And this fancy term here, looks like a little triangle, is Greek letter delta. And that means the change in. If I was calculating a slope, and you guys have all done this, you might alternatively see that written as delta y over delta x, because that's the change in y over the change of x, which is also the slope. Okay, so we're going to use this relationship here, and delta x simply means the change in the position of x. Okay, displacement describes how far you are from where you started regardless of how you got there. So if I wind up here and I started here, it means my displacement was this far and in that direction, in the direction of the arrow. When we have a quantity that's magnitude or size plus direction, we call it displacement, and we call it a vector in general. So any quantity with direction we call a vector. We represent it with an arrow whose length is proportional to the size or magnitude, and whose, the arrow points in the direction of the vector. Okay, so that's why I've used an arrow right there. For instance, if you drive 60 miles from Pennsylvania to New Jersey, you'll get a vector representation that looks like that, okay, along the x number line. You'll notice there's another possibility, right? We could draw vectors along y in the vertical direction, and also, if you want to just go crazy, we could also draw vectors in the z direction, okay, into and out of the monitor, the surface of the computer. If I take my endpoint after driving 60 miles from New Jersey to Pennsylvania, and I drive back 20 miles toward Pennsylvania, well, we now have actually 20 miles less, because the red vector, this one, right, is in the positive direction, but the green one is in the negative direction. So a distance of 80 miles and a displacement of 40 miles. Okay, so the displacement is actually delta x, or 60 miles minus 20 miles is 40 miles. And the change, or the distance, what I would do is I would just add the two sizes. So 60 miles plus 20 miles. You could think of it as adding the absolute values, and that would give you 80 miles. This would be the reading on the odometer in your car, or how far your car has gone, because the odometer doesn't care which way the car is pointing. It just counts up the miles elapsed. And the displacement, the 40 miles, is actually the distance from the starting point. Okay, so that would be the distance, displacement from the starting point. Okay, so this would be distance, this would be displacement. And there's our formula for displacement as a change in position. Measurements of distance can only be positive values, magnitudes, since it is impossible to travel in negative distance. Distance is size only. We call that a scalar quantity. Imagine trying to measure a negative length with a meter stick. Pretty tough. However, displacement can be positive or negative, since you can end up to the right or left of where you started. You can also have an arrow pointing to the right of or left directions, if you want to think about it that way. So this would be a positive displacement. This would be a negative displacement. Just think of the number line and where the positive is to the right of the origin and where the negatives are to the left of the origin. Vectors and scalars. A scalar, a quantity that has only a magnitude, a size. A vector, a quantity that has both a magnitude and a direction. So which are vectors, which are scalars? Time, at least in Newton's world, is always a scalar. Distance is a scalar. Displacement is a vector. And speed is a scalar. We'll be introducing the vector version of speed, velocity, in a little while, and acceleration, which we'll get to in a week or two, is always a vector quantity. How far your ending point is from your starting point is known as displacement. A car travels 60 meters to the right and then 30 meters to the left. What distance has the car traveled? Well, here it's a distance, right? So distance is going to be 60 meters plus 30 meters is 90 meters. You travel 60 meters to the right and 30 meters to the left. What is the magnitude and direction of your displacement? Well, the displacement is equal to final position minus initial position. And we have two of these, right? We have two of these. So I'm going to say that the total displacement is equal to my first displacement plus my second displacement. The first displacement is 60 meters to the right, so that's going to be positive. And my second displacement is negative because it goes to the left. And I wind up with a total displacement of 30 meters, which is 30 meters to the right of where I started. Okay, if that were distance, right, if we were looking at the odometer in the car, it wouldn't say 30 meters, even though we're only 30 meters away from where we started. It would give you the total distance traveled, which in this case would be 90 meters. Starting from the origin, a car travels 4 kilometers east and then 7 kilometers west. What's the total distance traveled? Well, we're going to add up the distances. And actually, let's do this. I'm going to say D1 plus D2. size only, no direction, right? So it's going to be 4 kilometers plus 7 kilometers is equal to 11 kilometers. Okay? D. What is the displacement? Well, let's see. I've got two displacements, and I'm going to include them both. And I'm going to pay careful attention to which way each one goes. So 4 kilometers in the positive direction and 7 kilometers in the negative direction. And it's going to be minus 3 kilometers. Or the total displacement is 3 kilometers in the negative direction west. That would be letter A. You run around a 400-meter track. At the end of your run, what is the distance that you traveled? Well, seems to me it would be 400 meters. I bet the next question is, now what's the displacement? I must be psychic. You run around a 400-meter track. At the end of your run, what is your displacement? Well, how far are you from where you started? 0 meters. You're exactly where you started. That's where you ended, and that's your displacement, 0. Okay, I hope that sheds some light on distance with a direction, also known as displacement.